So anyways, now from Mexico City, we have Jose Carlos Godinez. I hope that's how I say it.
Testing.
And he is here, and he is a professor of chemistry in Mexico City, and he's going to be doing chemistry of the image imprint. Let's try that again. Chemistry of the image imprinting process. And so, are you fixed up and ready to go? I think you are.
Yes,
how about your mic? Are you mic'd? You're all set.
Yes,
okay.
It's all right.
Good. Take it away.
Okay. Well, I will start this lecture as Giulio Fanti did yesterday by saying, in the name of the Father, and the Son, and the Holy Spirit. I'm happy to be here in the United States talking about the Shroud in front of this audience that shares with me and my colleagues the enthusiasm for this holy cloth. The Shroud is a gift given by God Himself to show us human beings that He is really alive. He does exist, and He loves us. This cloth, together with the tilma of Guadalupe in Mexico City, are the real evidence that God exists, and He wants the conversion of our hearts, and He wants the peace of the human race. Okay, let's talk about the Shroud. The Shroud is a linen cloth made basically of cellulose, which bears a faint yellow sepia image of a scourged man. Linen is a plant. All vegetable cells have a cell wall made of cellulose, polysaccharide. The Shroud shows bands. You can see the bands, suggesting that during the Shroud bleaching process, a thin layer of carbohydrates was deposited on its surface. And every yarn of threads was bleached separately. The responsible of the image are the yellowish of individual fibers due to the chemical changes of cellulose or the thin coating of carbohydrates, or both. A fire in 1532 caused severe damage to the Shroud while it was in a chapel in Chambéry, France. Ironically, this unfortunate accident helped us to understand how the image was formed. The image in light scorches reflectance spectra looks very similar. You can see both similar spectra. The same compounds present at the light scorches are also present at the image fibrils. I'm talking about the light scorches. The microchemical tests carried out to the image area found that only aldehydes and carboxylic acid tested positive. These are the microchemical tests. Phenols, riboflavins, steroids, indoles, lignin tested negative. Porphyrin, because it's positive just in blood. Pyrols, creatinine, uric acid, negative. Urea derivatives, nitrogen base, negative. Amines, just positive in blood. Soluble pigments, negative. And only aldehydes and carboxylic acids tested positive. Okay, an unknown process causes oxidation and dehydration of cellulose or the carbohydrates of the thin coating, forming a yellowish chromophore bearing an aldehyde or a carboxylic acid group with alternated double and single bond systems, what is called conjugation. The image fibrils were oxidated and dehydrated. The scorched fibrils are even more oxidated and dehydrated. The clear areas are less oxidated and dehydrated. The image is not a scorch. Image is formed by many yellow sepia stains. each thread presents the same tonality, what is called the half-tone effect. The darker the area, the more numbers of colored threads, just like an image in a newspaper. It's a very important feature. The image is very superficial, 200 nanometers. The interior of the thread's medulla is colorless, while the light scorches interior is not superficial. Medulla is colored. It does not present the half-tone effect. Image was not produced by a scorch, fire, or intense heat. The hypothesis of a hot statue can be discarded. Let's see this low-temperature pyrolysis mass spectrum of an image sample. It detected the presence of 5,5-hydroxymethyl furfural with a molecular weight of 126. You can see a line here. 126 line is hydroxymethyl furfural. This compound is really there. The question is, was this compound forming part of the image, or it was formed in the inlet of the mass spectrometer? Let me discuss these two options. The pyrolysis mass spectrums reach low temperature, perhaps less than 100 degrees Celsius. Cellulose starts to degrade at 217 and 300 degrees. Then it is unlikely that HMF was formed in the inlet of the spectrometer from the cellulose. Pyrolysis had not yet started. Assuming that this compound was produced by the degradation of the thin coating in the inlet of the mass spectrometer, these carbohydrates also begins degradation at 140 degrees. So we can be sure that this compound was not formed in the inlet of the pyrolysis mass spectrum. It is better to assume that this color, with a yellow sepia color, was already there forming part of the image sample. Non-degraded carbohydrates are colorless. Furthermore, same spectra mean same compounds. HMF is present at the scorched areas, so HMF should be at the image. Recall, the image is not scorched. Obtention of this compound. Hydroxymethyl furfural is just a pyrolytic product. Yes, it is, produced by fire. Nevertheless, this compound is not solely a pyrolytic product. It can be obtained from the degradation of the carbohydrates in an hydrogen-rich environment, or a photolytic degradation carried by short-wave radiation, ultraviolet, or a combination of both. Let's see the chemical reaction induced by the burst of short-wave radiation released from within the body of Jesus. Here we have the cellulose. At the top, we can see polymer cellulose. This is a shroud. Shroud is made from cellulose. This is a shroud. This compound was unaltered during 3 days. While Jesus was laying in the tomb, this compound, the shroud, have this chemical structure. At the third day, when Jesus resurrected, the chemical bonds of the cellulose broke down, and we have monomers of glucose, which is very an hydrogen-rich environment. This is very important. You must recall in your mind at the end of the talk. Okay. The second step is the glucose rings opens. Here, the bonds break and forming an open structure. The third step, between carbon 2 and carbon 3, it loses water by an beta elimination. causing an enolate. At the fourth step, carbon-2 suffers oxidation by losing water between carbon-2 and carbon-3, forming a carbonyl group. In the fifth step, a furfural ring is formed between carbon-2 and carbon-5, making a ring furfural. And finally, hydroxymethyl furfural is formed by losing water. This compound can be proposed as the image shroud chromophore. Look at the color. It has an aldehyde group and a single double bond conjugated system. Look at the top. And look at this color, this image chromophore. Now let's see the HM fluorescence behavior. Hydroxymethyl furfural absorbs radiation at 284 nanometers. It does not show any fluorescence at this wavelength. Fluorescence has a bell-shaped profile. At 284 nanometers, does not fluoresce, but at higher or smaller wavelength, it does. The stir fluorimetrics were carried out at 376 nanometers, showing that image showed small fluorescence. Here, fluorescence analysis, you can see at the top, the clear area, then the calf, the neck, the nose, the heel. At this wavelength, 365, image shows fluorescence less than the clear areas. You see the clear areas at the top, and the image is less than this area. The scorched area shows fluorescence because the concentration of this chromophore, hydroxymethyl furfural, increases. An Italian group radiated linen cloth with ultraviolet xenon fluoride lasers at 196 nanometers, breaking the chemical bonds of cellulose. You see here the intensity is higher, it's increasing, and its yellow coloration appears as a function of intensity. Look, what they obtain is, it looks apparently a yellow coloration, looks very uniform. This looks like with at the naked eye. But under ultraviolet illumination, different fluorescent zones appear. At zone 1, the middle, high intensity shows fluorescence because it was done at 196 nanometers. The intensity is high. At the zone 2, the intensity is less, so it does not fluoresce. And at the outside, it doesn't too. At the shroud, the clear areas fluoresce. That's the background linen. At the second, the image does not fluoresce or presents small fluorescence, quenching the fluorescence of the background linen. At zone 3, the scorched area fluoresces. Hydroxymethyl furfural concentrations increases. Now, let's see, return to our pyrolysis mass spectrum of an image. This is from an image. We can see the largest peak of this spectrum was 131 atomic mass units, which is in fact the largest line in this spectrometer. What does this mean, or which compound can be? There is an unknown compound at the shroud that no one knows what it is. This line corresponds to an unknown compound. You see hydroxyfurfural, there's many lines, but this biggest line is an unknown compound in the shroud. There is 131 atomic mass units that no one knows what it is. It's a weird compound. Let me present some possible candidates which can explain this unknown compound. Ray Reuters assumed that this 131 unknown compound was amino acid hydroxypro- hydroxyproline, but the image sample did not contain blood. So this amino acid can be discarded. Latendresse also suggested other amino acids such as creatinine, leucine, could explain this 131 line. The protease in first Camin test ruled out the presence of nitrogen, so this amino acid can also be discarded. Beta suggested a contamination of alkane hydrocarbon from the many candles that have burned in front of the shroud. But the spectra of hydrocarbon looks very different with the scorching areas, so it can also be discarded. Latendresse also suggested a carboxylic acid, 7, from the secretion of the sebaceous gland of the many hands that have touched the shroud. Carboxylic acid is an alloid group, yes it is, but its spectrum does not show any signal at 131. So this 100 compound cannot be 7. In a totally independent experiment, cellulose was pyrolyzed. This compound was obtained, these compounds, but no 131 compound was detected. On the basis of what can be discussed so far, what could be this unknown 131 compound? The image chemical analysis did not detect any shroud material other than carbohydrates. Then what? Now, if it is assumed that in the Turin shroud there is the presence of hydrogen strainlet, then it can explain this 131 atomic mass unknown compound. What are strainlets? Ordinary matter, wood, metals, water, human beings are composed by two types of quarks, just up and down. When an extra quark exchange is added, a strange quark model is formed. Strainlets are conglomerates, nuggets, of strange quark matter. They're heavier than ordinary matter. Quarks up, down, and strange is heavier. They have in sizes ranging from about atomic nuclei, varying positive charge. Look at this chart. Ordinary nuclear matter has an energy of 930 atomic mass units, but a three-flavor quark matter, up-down strange, has an energy of 837 atomic mass units, even more stable. Oh. What can I do? Yeah. Yes.
Is it?
No?
Okay, this is moving, that's not.
Yes.
There we go.
Okay.
Everybody else is powered to it, too. It's all good. What's causing problems?
Yes.
These rooms.
Yes. We're in number, I don't know. Put it back, more, 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 more. More, 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 more. Yeah, more, 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 more. Yes, okay, from here. I handle.
Is that correct?
Yes.
Okay.
Okay, thank you very much. Well, okay. So we're saying that strainlets are conglomerates of nuggets of strange quarks matter. They're heavier than ordinary matter, up, down, in strange ways more, with sizes, with ranging from about atomic nucleus bearing positive charge. We are saying this chart. We were saying that ordinary nuclear matter has an energy of 930, while three-flavored quark matter has 837, even more stable. Strange quark matter is even more stable. Strainlets are absolutely stable, so physics are looking for them in environments like lunar soil, mineral deposits, top of the mountains, deep sea, cosmic sea. A physics one can walk with a strainlet bomb in his pocket without being sold. Here is a periodic table of strainlets. Every element strange has a mass greater than ordinary elements. Now, assuming that one hydrogen strainlet, we see the hydrogen, recall the hydrogen-rich environment. Then, if we look at this hydrogen strainlets, they have two values, 10 and 5. If you took the atomic mass from 5, which correspond to a more stable system, and it was introduced at the hydroxy material furfural, or just being trapped within the exterior, recall hydrogen environment, its molecular weight would increase from 126 up to 131, accounting in this way for the 131 unknown molecule. See? It was like yesterday, Bob was telling us that it's just like realize that what Bob said about the neutron capture by nucleus, the mechanism is very similar. Let's look at how these strainlets could be introduced into hydrogen nucleus. No. Curious. It can be some hydrogen. What about? Hey, it doesn't work. What about? What's the problem? Oh, here we go. Oh, is it here? I can see it there. Okay, well, it could be in other hydrogens or in another one. Yes, just like the neutron capture that Bob was mentioned yesterday by a nucleus. It's the same mechanism. Now, this study is not conclusive, and more research is needed in order to confirm this. Is that if this hypothesis is true, it has tremendous consequence. Not just that the Shroud has evidence of Jesus' passion, or evidence of his death, or evidence of his resurrection, but because strainlets are the cleanest signature of the formation of quark-gluon plasma, the Shroud can also have evidence that God created the universe. Up to now, the vast majority of the studies carried out to the Shroud has been focused to search the atoms and molecules' other electronic part. That's spectroscopy, radiation, chemistry, so on. Today, it is time to start the search of the nuclear inner pair of atoms and molecules that conform the Shroud. This is still unstudied part of the Shroud. Shroud's nuclear studies will surely in the future unveil many secrets that until now has remained hid. So they will continue overwhelming us as they have done until now. Thank you.
So we'll head for lunch. Now we have food that got.
What is a strangelet?
Well, it's if you are an ordinary Mary has two quarks. We all humans, ordinary Mary, are formed by two types of quarks, up and down. If you are an extra quark and a strange quark, it forms a strangelet, squared strange quark matter. That's what's strange.
Does anybody have any questions? Does anybody have any questions?
How can I take off this?
This is yours.
Yes.
Okay. Thank you, Carlos. Thank you very much. That was great. Thank you. And now for something very exciting, lunch. And it's going to be right over there. And if you don't have a ticket for lunch to join us, it'll be $15. And there'll be someone over there at that table over there. You probably have already, most of you have already bought lunch as part of your package. But if you haven't, then you can do it a la carte. And has anyone figured out how to do that neutron dance yet? I would like to have some volunteers up here later. And so lunch is served.